Welcome to two GCSE higher tier exam questions on the cosine rule. In the first question, we're given a triangle and we're given two sides and an angle and asked to find the third side. It's not a right angle triangle, so we can't use basic trigonometry. We need to use sine rule or cosine rule. The one that applies in this case is cosine rule, and you can find the formula for cosine rule at the beginning of the exam paper. In this triangle, we can find the side little a if we know B, C and the angle in between them. And that's precisely the case here. We've been asked to find this side, which I'll call little p, because it's opposite angle p. We know the other two sides and the angle in between them. So cosine rule for this triangle says that p squared is equal to 10.5 squared plus 8.3 squared minus 2 multiplied by 10.5 multiplied by 8.3 multiplied by the cosine of the angle in between them. That's the cosine of 62 degrees. Now we need the calculator. (10.5 squared plus 8.3 squared minus 2 times 10.5 times 8.3 times cos 62, and on this calculator you put the angle in and then hit the cos button, equals 97.31. So p squared is 97.31, which means p is the square root of 97.31. Square root to three significant figures we want the answer, so that'll be 9.86. 9.86, and the units are in centimetres. And if I give the answer in the terms they pose the question, they ask for QR, so I'll say QR is equal to 9.86 centimetres. In this second question, we're asked to find an angle when we know three sides of a triangle. Again, cosine rule can help us here. But unfortunately, the formula in the front of the exam paper doesn't give the angle form of the formula. So we first need to rearrange it. I need to rearrange this formula to make cos A the subject. I'm first going to take it to the side where it'll be positive. So 2BC cos A, moving it across to the left, is equal to B squared plus C squared. And I'm going to take this a squared to the other side, so it changes to minus a squared. And now to find cos A, I just divide by how many cos A's I have, 2BC of them. So the formula becomes b squared plus c squared minus a squared, all divided by 2BC. Now let's see how that relates to this triangle. We're saying the cos of this angle is this side squared plus that side squared minus that side squared, divided by 2 times this side times that side. Let's go back to the question. I can say cos A is equal to b squared plus c squared minus a squared, that's the opposite side, there's the negative one, divided by 2BC. So cos A will be this side squared plus this side squared minus the opposite side squared, divided by 2 times this times this. So that's 10 squared plus 12 squared minus 15 squared, divided by 2 times 10 times 12. And now I need to evaluate this on the calculator. (10 squared plus 12 squared minus 15 squared equals, so that's the top, divided by, and I'll need to open a pair of brackets to work out the 2BC. So what I'm actually doing is thinking of it like that. So it's 2 times 10 times 12, close the brackets, equals, so cos A is 0.07916. Cos A is 0.0791, and then the 6 is continued. So A, the angle A, is cos the minus 1, the inverse cos function. If this is the cosine, we use the inverse cos function to get back to the angle. So it's cos the minus 1 of that. So the inverse cos function, usually you have to use the shift button to get at this function, and that gives me 85.459. Given the answer to one decimal place, that'll be 85.5 degrees. So A is 85.5 degrees. And that completes the question.